we're going to do a CK12. I would recommend, is that good? You're happy with that? Okay. I would recommend, if you were looking at your phone, by the way, go ahead and put it away now if you were using it for Infinite Campus. I didn't tell you you could, but I'm not angry at you. Put your phone away. Oh, that's a calculator. And I am recording this just because sometimes you guys surprise me. And if I do a good enough job teaching it, it might turn out okay. We are on 6.4 in CK12. And the lesson is on faults. And what I want you guys to think is what usually comes to mind when we think of faults, and specifically in the geology field. Fault line. Do we know what a fault line is? Huh? A flat line? Okay. Okay, the ground might change or move along the fault. Good. Okay. If you've got the ground moving along a fault, that's a fault line. But what might be the result of that movement? A quake, an earthquake. Good, good, good. All right. So we're there now. This is a beautiful picture of Lake Crystal Springs Reservoir. It is a long, straight lake. And it's that way because it is along a fault line. One side of it in relation to the other has dropped along the fault. So you have a low spot where water filled in. Simple, right? Would this be, it asks the question, would this be a good place to build your home? Why not? Because it's where earthquakes happen a lot? Do you think nobody be dumb enough to build their home along the San Andreas Fault? You think there are some dumb people? Yes. So mean. You guys want to, so okay, but why? Not all, guys, they can't all be that dumb to like purposely like know that there is a fault line and still choose to build their home there. Why would they do that? Let cheaper land, he says. Okay, let's think about this for a second. We're talking about an area, I'm going to pull up Google Earth. We're talking about an area from San Francisco roughly to just past, right, Los Angeles. Now, I want you to think for a second, everything you've heard on the media, news, maybe you watch House Hunters on HGTV, whatever it is. Are land prices, real estate prices, home prices cheap along the coast in this area of California? No, they're kind of, to our standards, whoa, that's expensive, right? Because we've got relative to that, we've got really cheap. They'd look at our real estate and say that's really cheap. So why would they be willing to pay so much to live in a place that is riddled with earthquakes? I mean, every generation they have a relatively powerful earthquake. Why would they do that? To be close to the beach, okay. Location, location, location. What's special about the beach? And people will pay to be in that location. Especially, like, so think tourist industry, that's a big piece. Yeah, and that hasn't come up today in the other classes. So if you are in the tourism industry, you're probably going to live out there and you're going to cater to the tourists, which bring you their money. So you can afford, you're taking that risk. Yes, we're living in an earthquake-prone region, but the reward to that risk is we'll be successful in our business. Okay? Look here. San Francisco, why might people specifically, other than the tourism industry, be willing to live in San Francisco despite there being earthquakes? It's not a lake. That's a... Guys, what is San Francisco? City. It's a city. What else is San Francisco? No? There is a Golden Gate Bridge. Now, the Golden Gate Bridge separates, it crosses the inlet to the what? It separates the Pacific Ocean from the what? Somebody said it's a lake. It's a body of water. It's not a lake. What is this? Bay. It's a bay. It's actually a series of bays. Together, we know them as San Francisco Bay. And because of how good a natural protective area it is, protective for what? What sails on the water? Ships, boats. It's used as a safe, H word, haven, safe, water word, harbor, safe harbor. Okay, so, and it's on the west coast of the U.S. What is on the other side of the Pacific from the west coast of the U.S.? Huh? Don't you dare say that. Let me back out. Guys, what countries are these? China, Taiwan, Japan, South Korea, Vietnam. Take off your tennis shoe. Remember we did this in 7th grade? Take off your tennis shoe. See if the tag's still on it. They're looking at me like I'm nuts. Take off your tennis shoe. Your running shoe, your walking shoe, whatever you had. Take it off. Is it zooming in? Is it focused? Okay. So mine says made in Indonesia. China? Vietnam? Cambodia? And that's a daggone cowboy boot. Or cowgirl boot. Shh. All right. Shh. Oh, Mexico? Good. Okay. So, look. Look. China. Somebody said Cambodia? Did somebody say Cambodia? Where the heck is Cambodia? Isn't that in here somewhere? Good grief. Yeah, right here. Vietnam. Somebody said Vietnam right here. Mine said Indonesia down here. Yours says nothing? Okay, cool. It probably wore off. All right. I will. I will. What?
So how are the days like so much more dirty?
Okay. All right. Let me zoom back to it. All right. Shh. So let's go back to San Francisco Bay. So this water out here is quite deep. And the sediments can settle way, way down. In here, the water is much shallower. And it gets kicked up. And there, my guess is, I don't know, my guess is there's some rivers, yep, and estuaries that feed into, so they're carrying silt with it, right? A little bit more muddy water. So that's why it looks a little different. So the depth of the water and what's in it is why it looks a little different. But look at this. Let me back this out. Back out and then zoom in. Where did I find? Yeah, the bay's right here. No, I'm looking for stuff that's very specific. All right, so right here we have the USS Hornet, Sea, Air, and Space Museum. So if I zoom in here, what in the world? What is that? It's an aircraft carrier, okay? Guys, Alameda is a major naval base on the west coast of the U.S. You put your ships in there to protect them from rough seas, right? So if the U.S. Navy does that, do you think anybody else wants to put their ships and boats in there? Sure. Sure, look at this. Look at all those boats, private boats. And you can actually go around a lot of the area of the San Francisco Bay, and you'll find more. Oh, this one's fun. Alcatraz, right? The old prison there. If I keep going, and I forget exactly where it was, I can zoom in and find plenty of other boats, ships, whatever. There are some port facilities. I'm not going to waste my time looking for them on here. You guys can certainly do that later. Giant cranes. Have you ever seen port facilities, like maybe a news program or something? And the ship comes, the crane goes, and it lowers down these cables and little grapplers, and it grabs the cargo containers. So those cargo containers have all of the stuff that we buy on Amazon. Okay? So now it doesn't work like, oh, I'm going to order it, and the guy in China gets the order and says, oh, we got to send this out. It can't possibly go that fast and go through all, because it takes months for that supply chain to go from supplier to customer. Yes? Amazon has localized, regional, whatever, warehouses, right? So they pre-locate, and their algorithms tell them, we know there's going to be a certain number, approximately this many orders per day, per week, per month. And they pre-locate that stuff in the warehouses so that when you click on it and put it in your cart, it'll say, ooh, overnight delivery available. Or next day. You ever see that? Okay. So that's how it works. The port facilities, though, that's where it comes on the cargo ship. The crane picks it up, puts it off, they get moved off, and then they get put on a truck. And then the truck delivers it to the regional warehouse. And then the delivery trucks go to the warehouses, and then they take out, and it says, out for delivery. You guys seen out for delivery on your parents' phone or whatever? They're like, oh, your thing's coming. Okay. So San Francisco is a major port facility. A lot of the U.S. imports come in there. Do you think there's some money flowing in and out of San Francisco? Do you think there are some people that, because there is the bay there, despite the fact that there's a daggone fault line, they're going to build their homes and businesses there anyway? Now, when a lot of these towns were first established, did we know about plate tectonics like we do now? Did we know what caused the earthquakes and whatnot? If you go back far enough, what did most people say? Like, there was an earthquake. What was the cause? Did you hear about that village 2 days ride from here? Basically flat, you're laughing, like flattened. What the heck did those people do to tick off the gods? Right? Like, woo, they brought somebody. What's the expression now? You play, what is it? You play and you play games. You play stupid games, you win stupid prizes. That's what they were thinking back then. Maybe not with those words. Like, they shouldn't have messed around. Yeah. So, okay. That's a good example. Hollywood. How many of y'all are movie lovers? You like movies? Most movies, what's the mecca of movie making? Hollywood. Hollywood. Most of you have your computers open. A couple of you are completely ignoring me and looking something else up. That's fine. Google, when was like Hollywood founded? Just Google Hollywood. When was it founded? 1887, the town of, okay. 1911. Change your Google search. When did Hollywood become the film mecca of the world? Something like that. 30s? 20s? Look, I don't know if you looked that up or not. I agree. I think it's the 20s, 30s is when Hollywood became the thing. Guys, when did we figure out what makes the continents move, how the seafloor spreads, how the plate tectonics works? It was the 30s into the 40s, sonar, right? Late 40s. The whole thing, you take the seafloor spreading, continental drift, slap it together, you got plate tectonics. The whole thing really didn't come together real well until the late 50s into the 60s, when more people like understood, okay, this is what's going on here. So Hollywood was already there. San Francisco was already there and prosperous, despite occasionally having some natural disasters. So they know now, okay, this is going to be a recurring thing, and we know why. Do they up and leave? Maybe a few. If you ever watch interviews after a disaster, people are like, that's it, that's the last one, I'm gone. I'm not dealing with this anymore. It's not worth it. What do they mean it's not worth it? It's not worth the extra. So they're taking a risk by living there, but they know they're going to get a reward because of whatever industry they're in that location. And they've decided that's fine. I don't care. I'll move to Kentucky. I'll make less money, but the cost of living's less, and I won't have to deal with these daggone earthquakes anymore. I hope they don't settle on the western side of Kentucky, because there's another fault there, isn't there? The New Madrid fault line, pretty big earthquake. I think the New Madrid fault line can actually be just as powerful or more than the San Andreas earthquakes. But even if they come out here, they could get flooded, right? We've got our own problems. Yeah. We got daggone muddy water all over the place, or do they get? Do they have tornadoes in San Diego or San Francisco? Not so much. Yeah, not so much. But they'll come here. They might have to deal with tornadoes. So what's up? Yeah, they wouldn't even bother really. So do we have earthquake drills here? Yes. But we're like, what, 300 miles? Something like that away from the nearest major, like the New Madrid. So we still do them. Are there, I don't know. To answer your question honestly, I don't know if there's any place that's so far removed from a fault line that we know would cause damage. I don't know. Well, that's the thing, though. So there are some places that are removed from fault lines, but they get earthquakes now because of man-made problems. So like fracking. You guys heard of fracking? Trying to release natural stores of carbon-based fuels. They do mining techniques that can cause minor earthquakes. Nothing. I don't think there's anybody like a major earthquake from that. But anyway, so there's reasons you'd want to be there. It took a long time to go through that story, but I think it was valuable enough. Would it be a good place to build a home? Well, if the juice is worth the squeeze, if the reward is worth the risk, sure. All right, guys, fractures. Has anybody ever had a broken bone? What'd you break? Wrist. What'd you break? Elbow, ankle. Ooh, all the joint play. Ow. Anybody like have like a middle of a larger bone? What'd you? Your arm, humerus, ulna, or radius? Okay. So he broke his funny bone. That's not funny, right? Kind of hurt. How long did it take to heal? A year to fully heal? Okay. Question. Do you guys know the two, like if you divide all broken bones into just two categories, what are the two categories? Simple fracture and compound. Yeah, compound fracture. Okay, so in a simple fracture, the bone breaks, but it's not like moving. Does that make sense? It's still there, and you're not going to want to move it because it might, but it's broken in place. Does that make sense? With a simple fracture, it's broken, but it's still in place. Compound fracture, it's broken and the bone pieces are moving so much they're causing damage to the surrounding tissues, sometimes even coming through. Have you ever seen that? Coming through the skin? Ooh. Yeah, it is. It is disgusting. With rocks, bones are hard, sure, but they can break. Rocks are hard, sure, but they can break if you put enough stress on them. Enough compression stress, enough tension, enough shear, right? We talked about those. Absolutely. geological stresses, 6.1. Remember that lesson? It was just a couple weeks ago. If you don't remember, you might want to look back at that lesson, okay? Fractures, yep. If there is not movement for rocks, we don't call it a simple fracture, we call it a joint, which with the whole human body analogy doesn't work so well because our joints do move. In rocks, if you're talking about a joint, it's a fracture point that doesn't involve movement, okay? So, for example, right here, in the picture from a distance, that looks like a bunch of old railway ties just stacked up, doesn't it? But those are rocks. And as the lava cooled, first it would harden, but then it would continue to cool and contract and form fractures, cracks. But there's no movement between them, okay? So that's a joint. But next up we have faults. Faults are at fractures that there is movement. So there is movement between the rocks. If the rocks on one or both sides of the fracture move, it's called a fault. Faults can occur alone or in clusters. If they're occurring in clusters, it's known as a fault zone. Probably one of the not so great places to put buildings, but we still do if it's worth the risk. Here in Kentucky, if you want to build a stick-built home, regular wood framing home, you have your sill plate, let's say. So you got the deck of the building, you put a sill plate 2x4, and you put vertical studs, right? One right after another down the wall. Does that make sense, Di? How do you attach that stud to the sill plate and to the top plate? Generally not screws. You're usually going to use 2 nails. You're going to put 2 nails through the top plate and the sill plate into the stud. Now, if you did just that for that home in an earthquake zone, the sill plate is most directly attached to the ground, yes? So when the ground starts to shake, if you don't have more than those 2 nails, what's going to happen to those 2 nails? They're going to be They're going to be better attached to the sill plate than to the stud. The stud is the bottom where the nails go in. It's going to start to strip it. It's going to start to shred it. It's going to start to splinter. There, that's the best word. It's wood, right? It's going to splinter the bottom of that stud. Yes.
They're so cool. Their size
Okay. Okay.
You can see the tracks of the trucks. You can see the tracks of the bulldozers.
I have not, to answer your question, I haven't seen it.
We put like baby puppies in it too.
Yeah,
Maybe later. All right, so we could get away with that kind of construction here away from a major fault line, but in California, where they're near the San Andreas, for example, they might have the 2 nails. They probably have like requirements, building codes for like glue. They probably have I know they have building codes where they put metal brackets in the corner that attach several inches of the stud to several inches of the sill plate, so that when that earthquake shakes, it holds together. It moves more together. Does that make sense? It doesn't shred or splinter the wood. So what does that do to the cost of the homes, though? You're going to have to put more materials and time and labor into the building process, so the homes are going to be more expensive. Yep, more rules, more regulations generally drive costs up. But in that case, would you rather pay a little bit more for the house or have it fall apart in the next earthquake? Right? So it's trade-offs, always trade-offs. All right, the energy released when there's that fault that takes place, we know that as an earthquake. All right, we've got a paragraph here on dip-slip faults. I like pictures. Let's look at these pictures. So in other words, you have either the top piece being driven up or sliding down in relation to the bottom piece. And what we call those are hanging wall. The one on top is the hanging wall, and the one on bottom is the footwall. Footwall, hanging wall. Let's take a look at a picture in real world. This would be the hanging wall. And then what they're standing on here would be the footwall. Cool thing is, if you were like a miner, if it weren't for this, to get to these layers, you'd have to cut down through, right? But because you've got this exposed hanging wall, you can just walk right up and start chipping into the side, right? You can start cutting horizontally shafts to get whatever you're trying to extract. Strike slip faults. Guys, we've talked at length, I think, about strike slip faults specific to boundaries, okay? Because I tend to use transform boundary and strike slip boundary almost interchangeably, okay? In this case, you can have a strike slip fault that's not necessarily at a plate boundary, though, okay? When I use them interchangeably, it's at a plate boundary. What do you got? Daggone, passed out. Am I not loud enough? Am I not entertaining it? No, it's not. Oh, I like this. This is cool, guys. I really like this. This picture has, you see the fence? And then the earthquake happened, and now the fence line is in two pieces. And the cows are like, moo, and they're moving through. Like, dang it, we got to go get the cows. We know about that around here, right? How many of you guys have ever been going home or something? There's just a cow, random cow in your front yard. Like, what the heck? Oh, my heaven. Guys, the last house we lived into, I spent $8,000 putting in a new septic field in the backyard. New tank, new lines. It was a turtle shell kind, so it was a little more expensive. And they said, don't drive anything on it. It's just new. Okay. So that next year, the next spring, the root system of the grass hadn't even gotten fully, like, the sod wasn't fully formed. I come home, or was it next morning or something? We wake up and there's daggone cows, because it had been raining a lot. They're punching holes in my backyard. I'm like, my $8,000 septic system. Now, fortunately, we didn't have any damage, but oh my head, God. What? Mm-hmm. Wait, which one? Just a couple weeks ago?
That took out pretty much.
Okay, well, okay.
But we just did a fence.
Yeah.
And water went through.
Washed it out.
Around. Boats were everywhere.
Yeah. Bummer. Mm-hmm. Yep. Yeah. You should be putting it in right now. Seed in the yard. Okay. We're getting pretty warm. It's pretty good dry right now too. You can seed it right now. It'd be all right. All right. We've been through this. Hello. So this is mostly a review. Read through it quickly, and then you have your summary. Remember, the summary is the baseline of what should be like at a minimum in your notes. Plus any new vocabulary that you came across. You're like, oh, that's new vocab for me. Okay. There is a video in this lesson, and I'm told it's like some Khan Academy guy on this one. I got 18 seconds in, and I couldn't deal with the voice. It was very boring, monotonous. I'm not doing it. So you can watch it if you want. Otherwise, you certainly have my blessing to go in, Google search a video on faults. But I think you probably have enough to go ahead and answer the questions at this time. Let me assign it. And I'm going to make it due Tuesday. But I really do believe that you guys will have it done quicker than that. Whoops. I just assigned it to my military science class. Nope. Let me get it to you guys.